Hi friends. Check the sound. Sound. Hi friends. How are you? In this live class, right? Sound. Yeah. In this live class, I am going to brief you on the textile chemistry. Textile chemistry by dyeing. Friends, in my channel, Guruvira Textile and Fashion Technology Tutorials. Nowadays, uh, most of the videos are not released. Only shorts are there. And most of my channel, the subjects preferred by the audience are, as per my study, it is a textile chemistry. Compared to weaving, spinning, and other knitting and other subjects, textile chemistry is preferred subject accepted by the audience in my channel. So I'm very interested. I'm taken this textile chemistry as a part of my channel. What audience accept that I have to do it. So already in my channel, most of the dyes, reactive dyes, VAT dyes, direct dyes, basic dyes, acid dyes, most of the dyes are running successfully. And this sulfur dyes is what I'm taken live, the sulfur dyes. This I left, and one more dyes, modern dyes, dispersed dyes. These are the things are there. I have to go live or edit videos. Okay, friends, this in this live class, I am going to brief you the chemistry of sulfur dyes. Most nowadays, the global what the green chemistry is there. These are all chemistry, not only the textile chemistry, any food industry, plastic industry, cement industry, whatever industries, or pharmacy or medical, whatever the chemistry involved in the production of the products. These are all concentrated and monitored by the country's government legislative departments of the different countries. Now it is very tough for the chemists or chemical industries to produce the products which are not harmful to the human health or not harmful to the globe or environment. Restricted substances list RSL, like the substance, the chemicals which are used in the process of textile processing, like formaldehyde, like PVC, like phthalates, they're all banned. But sometimes some chemicals are going to be used. Even though in case of dyes also, even though in case of dyes also, what will happen? Most of the dyes are also banned. Most of the dyes means, say dispersed dyes is there. Not dispersed dyes means not all dispersed dyes. In dispersed dyes, some dispersed dyes which are harmful to the health, which are harmful to the environment are banned. And also azoic dyes is banned. Even sulfur dyes. Sulfur dyes also most of the in Western countries, sulfur dyes uh, totally not banned. They have avoided. They have limited or avoided to use it. But in case of Eastern countries, some countries they are successfully and they are using because sulfur dyes is a must in some products, in textile products. We cannot avoid it. That's the reason sulfur dye is also preferred not for the in bulk or everything. Some limited products it can be used. In black denims, the production of the black denims. What is the production of black denims? Sulfur black is used. Sulfur black bulk is used. Okay now. And in some case of coarse fabrics, mainly I'm telling you heavyweight fabrics. Heavyweight fabrics are required sulfur fabrics usually. Most the dark the fabric, which is having higher GSM grams per square meter, usually used for dark colors and bright tone. Dark colors, bright tone, usually use sulfur black or sulfur black or brown is used. This is what I'm going to give a little bit small introduction, friends, students. See, you know, you might have seen my videos on VAT dice. VAT dice is also the mechanism of application of the VAT dice is also similar to the sulfur dice. Sulfur dice application and VAT dice application both are same. Why the same? Compared to direct dice, compared to reactive dice, the sulfur dice and VAT dice similar in applications. Why? Because you see, dice which are sometimes used directly locally. Dice not only think that dice are used in the big industries, composite mills. Okay, even though local dice, local market, in cities, in village, in handlooms, to dye a handloom, yarns for handloom, to dye a yarn for handloom, to dye a fabric, local fabrics. Dyes are used, which are used not reactive dyes, direct dyes are used. The fastness, you see, most of the local dyes have poor fastness. Nowadays, you might have seen if you purchase low price bed sheets or pillow or home bed sheeting. If you go and purchase, if you wash after 1 month or 2 months, color will go. To see in the market, the designs prints are very good. Printed by the direct pigment, colors will go. So friends, okay, so reactive dyes, okay, na? Reactive dyes are, reactive dyes are strongly covalent bonds, strongly bound. That is other case. In this sulfur dyes are available in the form of powder. See what type of are there? Here types. Sulfur dyes, color index sulfur dyes. There are types of available in the market. Color index sulfur dyes are there. Leucosulfur dyes. Already the market production which is made, converted, soluble and solubilized sulfur dyes. These are the things are there. So, best friends, and first I'm coming to start. What are sulfur dyes? Sulfur dyes are not a natural dyes like indigo. It is a synthetic dyes like reactive dyes, like other basic and acid dyes. Okay, na? And also it is synthetic dyes. One point. Second point is organic dyes. Synthetic organic dyes. Why synthetic? Synthetic means it is a man-made. It is synthesized. Dye is synthesized in the lab. There is a chemistry is there. Chemical synthesis is there. And why organic? Organic is the raw material used for the production of sulfur dye is a natural, organic wood products like cellulose. How the cellulose substance like viscose with tensile fibers are produced from the wood pulp. Pulp is not taken. Wood products like sawdust, powder of the like the powder of the wood. That sawdust sulfur is available in the wood product. Wood product sulfur. Sulfur, the intermediate, the chemistry is required. That is the wood product is that wood product. That will wood. We'll see. Yeah, I'm not going in deep. What type kind of wood, where the forest, what type of forest, other things about it. What are the biology behind that? Just it's a thing that it's a wood product. It is treated with the sulfide, sodium sulfide. By combining wood products with the sulfide, say sodium sulfide, the product is produced by using the aniline derivatives. So, aniline derivatives, some derivatives reactions are taken place. Some agents, some catalysts, some reactive to make it reactions. Chemistry is used. Aniline derivatives are used. I would have written here 2,4-dinitrolophenol and sodium sulfide. This is one type of aniline derivatives. It is required to make it the sulfur reactions. See, the main point, now you understood synthetic and organic dyes. Second point, most compared to the other fibers, compared to the other dyes, sulfur dyes are insoluble in water. Let's join together. Insoluble in water. Sulfur dyes are insoluble in water. These are not direct what the sulfur is there. Produced sulfur, it is not dissolved in water. It is not dissolved in water. Whatever the available is there, market available. Okay. Now I already told leucosulfur dyes, sulfur dyes, solubilized sulfur dyes. Now technology is developed. Now technology improved. Science is improved. Now the question is there, water insoluble. That is what I'm talking. Sulfur dyes are water insoluble. That is a talk of the 100 years back talk. What in 1873? What the sulfur dyes in 1873? It is invented. It is occurred by accident. By accident, it has occurred sulfur dye. How sulfur dyes is come into picture? It is by accident. How? I'm telling you the story. Here in 1872, some in the lab sawdust. Sawdust is used in some one experiment. I don't know. I have not studied in deep the chemistry. The sawdust, the wood powder sawdust, is used to wipe the whatever the chemicals are there on the table in the lab. To clean the table, sawdust is going to use. Okay, whatever stainings are there, colors are there. AN is something water is there. So pour the powder and stain it. This is so that by using the powder as a agent, cleaning it was. What has happened? This sawdust and caustic soda. In that, by accident, caustic soda experiments. Some experiments might have that. I don't know in deep the story. History is saying sawdust and caustic soda. Eating the sawdust and caustic soda. Okay. In that, what will happen? Huh? Sodium sulfide Na2. Sodium sulfide is leaked. Sodium sulfide is leaked on the powder of the wood. Sodium sulfide is leaked on the powder of the wood. These are all by accident. What the lab experiment person is there while using that he may be a chemist, he may be whoever the lab he used Na2 sulfide. Okay, in the vessel. By mistake, what has happened? Sawdust and caustic soda in that phenomena, Na2S sodium sulfide is that the mistake it is added, it come in contact with the sawdust, chemical reaction might have taken place. Okay, then what will happen after that? That's mixture of sawdust, sodium sulfide, whatever is there, that come in contact with the cotton material. That cotton material gets dyed. That's stained. It's stained. Cotton fabric gets stained. So the chemist, the scientist, whoever the person came to that, how this cotton fabric gets stained. It is not removable. Stain is not removable. Permanent stain has happened. So the doubts started to invent that color. How the sulfur dyes? Then they thought they studied sawdust was there. Sawdust was there. Okay, sawdust was there. Sodium sulfide mixture of sodium sulfide and sawdust that is react and caustic soda was there. Then stained on the cotton fabric. It shows that staining happened. So it means dyed. Fabric is dyed. This is also one kind of dye. Then started This phenomena done by accident started then in 1980, in 1893. One company, Vidal is one of the company produce Vidal Black. It is a Vidal Black. Now also the textile industry is using Vidal Black. Now also the textile industry is using. Okay, now also textile industry is using Vidal Black. Correct? You can hear textile industry, dyeing industry. Vidal Black is there. It's a popular name. Vidal Black. Vidal Black is a technical term, but sulfur black one. It's a trade name. Sulphur Black 1 is a trade name for the Vidal Black. Vidal is a company in 1873 produced the black color by using paraphenylene diamine. By using paraphenylene diamine with Na2S. Na2 is sodium sulfide and sulfur. Sodium sulfide and sulfur, by mixing of sodium sulfide and sulfur, they produced the first synthetic dye called as Vidal Black color. Okay, now then this Vidal Black, this phenomenon, this Vidal Black, now it has become a Sulphur Black one. See here, friends. Okay, one more I'm telling you. Cachot de Label. Cachot de Label is one of the historical name behind the sulfur dyes. This is the forerunner. It is a forerunner for the sulfur dyes. How it is produced? Wood products plus sulfur sulfide source mixed and produce Vidal Black by enhancing or by what you call by the reaction with aniline derivatives. Aniline derivatives. What the derivatives they have used? Aniline 2,4-dinitrophenol and sodium sulfide. Okay, this is that. This is how next what happened one month after 1897. In 1897, one of the other company, Kali Share company, produced okay immediate black. Yeah, not immediate, immedial black. First Vidal Black, next immedial black. Immedial black is used by using what the derivatives 2,4-dinitro-4-dehydroxy diphenylamine with sodium polysulfide. Basic requirements for sulfur dyes, wood products and sulfide. But different companies produced by adding different aniline and align derivatives. It's depend upon the companies to companies. Vidal Black company, Vidal used 2,4-dinitrophenol, and this Kaleshar company used 2,4-dihydroxy. So these are things are there. That is different, and also they will get a patent for their product. And later, now technology developed, so on, it is going on. And on the other hand, also environmental issues, also there for sulfur dyes. Environmental issues. Environmental issue is there. What environmental issue is there? Nowadays, green chemistry is there. Everybody talks about the green chemistry, everybody talks about the restricted substances list for the global or retail market of the textiles and apparels. The challenge is restricted substances list, maintenance of the avoiding of the toxic chemicals in the textile processing. This is one of the challenge for the textile and apparel industries, also for the footwear industry. So, because to protect the human health and environment, these are all things. Even though, okay, this effluent, whatever the production is sulfur dye, after sulfur dyes production, whatever the effluent is there, no, effluent is not suitable for the environment. That is toxic in nature. That is one question is there. It is not suitable for the environmental issues there. And also the technology developed to avoid, to make it suitable for the environment and not to be hazardous for the human health. So many extra technologies adding nowadays. That is, uh, I don't think we'll see in the next videos. It is a big topic. Now, for the students of the diploma, BTech, MTech students, or even those who are studying in textile industry, whoever the IIT or Delhi, whoever is there, or industries, they can further what is alpha dye is there. Okay, now this is about the history is there. Now I'll come. What this diagram is there? This is not like this diagram. Now I'll talk about this diagram. This is the diagram. Chemistry. Chemical structure. This is the chemical structure of sulfur dyes, especially structure of sulfur black 1. Sulfur black 1 is there. In this sulfur black, what you can see? S, N, S, 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 N, R is there. Yes, these are whatever the S are there, those are the sulfide linkages. First of all, this is the aromatic compound. Aromatic, this first of all, this is the aromatic compounds. Sulfur dyes, the chemistry, the inside of the sulfur dyes, what chemistry is involved? It is made up of aromatic compounds. These are all the aromatic compounds, aromatic rings. What these rings are, they're linked to each other. These are all called, these links in what forms are there? Heterocyclic rings. Heterocyclic rings. They are called heterocyclic rings. This is one structure is the R. This is bonding. Chain is. This is chain. Sulfur linkages are the nitro. And also I'm telling contain this sulfur dyes contain what? Like what it contains sulfur dyes? Contain amino or nitro groups with a sodium polysulfide and sulfur. Sodium polysulfide and sulfur. Poly. What is poly? See S S S S S S. Number of sulfur. What linkages are there? Not 1, 2, 3, 4, 5, 6. Single sulfide को हम इधर what is given dash S dash is there. Disulfide double S is there. And polysulfide n number of S. N number of sulfide. Polysulfide is there. This is a structure and nitro group. In this structure nitro group is there. It may be an amino group also. Okay, na? This is a sulfur dye. This is one part. Okay, na? And also this is a non-ionic. Non-ionic. What is in ionic and non-ionic? You can see in where? In basic dyes and acid dyes. I have discussed about the ionic and non-ionic. There is chapter of basic and acid dyes. You can check it. Now I will not take that subject. Here just I am saying this is a non-ionic. Here there is no anion, cation, those structure is not there. Okay, and now what I said, this is a water insoluble dyes. If it is a water insoluble dyes, then how to dye? What is the mechanism involved? What mechanism is involved? Students of BTech, students of diploma, students of MTech, those who are all in India and other, especially my videos are, especially my chemistry videos, textile chemistry videos are watched in Canada. Those who are in Canada, those who are in American other states, California, even most, what I'm saying, I analyzed my textile chemistry videos are watched by Americans. Okay, because questions and messages are received. However, students, this in water insoluble mechanism. First, what to do? Like wet dyes, water insoluble sulfur dyes are converted into soluble form. That is soluble form. That soluble form is called leucoform. Insoluble sulfur dyes are converted into water soluble form, that is called leucoform, by breaking the molecules of the sulfur and sulfides. Okay, now by using how it breaks, what by means of using reducing agents, by using reducing agents, by using reducing agents like sodium sulfide, sodium sulfide dilute aqueous, by using dilute aqueous sodium sulfide Na2S, this is a reducing agent. This by using this breaking of the dies, breaking of the dies. What is that? Dye SS dye is there. There is water insoluble is there. It is break into small levels. How it should dissolve in water, like sugar in water, sugar in milk, like that. By using a reducing agent or solubilizing agent, that agent makes this dye into solubilize in water or reduce and solubilize in water. After reduction, after reduction, what the solution available, solution produced, that solution is a water soluble. Here, whatever S sulfide linkage is there, after E sulfide linkage react with the sodium, this sulfur linkage, okay, sulfur linkage S react with the sodium sulfide, uh, produce SH. H is a reducing agent, S is a sulfur, and producing SH. This SH will dissolve in water. This SH is dissolved in water. Okay, now, so water soluble. This soluble form of this solution is called leucoform. This leucoform is a substantive. Substantive for what? To cellulose. Substantive for cellulose. Cellulose means natural fiber, cotton, regenerated fiber, viscose, tensile, lyocell, modal, or even the blends of synthetic fibers. Synthetic fibers, once polyester, nylon. If polyester is mixed with cellulose, cotton, or viscose, if nylon is mixed with cotton or viscose, those blend also can be dyed for black color or brown color with this. Okay, now this is the, so what I'm saying, this sulfur dyes is mainly used for cottons, viscose, cotton and viscose, sometimes synthetics, wherever blend is there, more blend, say 65-35, not 65-35 blend, cotton polyester, 35-65 is a polyester, usually 65-35 is used for lining and other things, fabrics, 65% polyester, 35% cotton, so cotton percent is very less, so it's not 6, where the cotton percent is more, then it can be used instead of other direct dyes or reactive dyes. Mainly, I think as per my experience in the industry, heavyweight fabrics like denims, black denims. Okay, now once the dye converted into leucoform, water soluble, that solution is used to dye a cotton yarn or cotton fabric or any cotton material or any viscose materials. Okay, now, so we're going on live. Right there. So it's going on. So water soluble. This solution is used to dye the material. Dyeing mechanism, it is a common material to laker ratio. What is the how much length of the fabric is taken, for how much weight of the fabric is taken, for that what solution to be prepared, material to laker ratio, agents, other things, global salt. Here also global salt is required, is used. That is common application method. Is I will come into picture. Now I am telling I will come into application method. Now this leuco form of the sulfur dye is used for dyeing. Once the fabric gets dyed, once the yarn is gets dyed, dyeing is complete, then it is taken for washing. After washing, okay, after washing, what will happen? Then it is taken for next process, that the fabric Suppose fabric I'm talking. If the fabric dyed with the lukewarm of solution, then the fabric, whatever dyed is there, that it is absorbed. That lukewarm solution is absorbed by the cotton fabric. Okay, cotton fabric absorbed by cotton fabric or viscose cotton fabric. It is on the surface or into the fiber structure. Okay, now on the surface of the fiber or into the fiber structure. Absorption or adsorption. Yes. But if it is sent for finishing and marketing, what will happen? What will happen? It is a water soluble. It is fabric is dyed with the water soluble. Then that finished fabric is then what will happen? If it is washed or laundry, then wash fastness will be poor, laundry fastness will be poor, color will bleed. So what to do? The sulfur dyes, once the fabric is dyed with the lukewarm soluble, water soluble form of the sulfur dyes, then after dyeing, after the solution is absorbed by the fiber, cotton fiber on the surface or into the structure of the fiber morphology, then again that fabric is taken for oxidation, oxidation or airing. Oxidation is required. Why? Oxidation is taken for oxidation. In oxidation, what will happen? Again, due to the oxygen present in the environment or by using oxidizing agents, whatever the water soluble form of the chemical is there or dye, that again reconverted into water insoluble within the fiber or on the surface of the fiber. Wherever the solution stick to the fiber or go into the fiber, structure of the fiber, wherever it is there, at what level, at what depth it is dyed, affinity taken place, depth of a dye takes place, that much of a dye is reconverted, returned back to the water insoluble form by using the oxidizing agents or by exposing to the air. By exposing that dyed fabric to the air, that is called airing, or in sometimes oxidizing agents are used. The oxidizing agents means sodium dichromate, Na2Cr2O7, sodium dichromate. This is also an oxidizing agent. Hydrogen peroxide is also oxidizing agent. Sodium bromide, oxidizing agent. If time is there exposed to air, if small quantity is there taken back outside the factory and exposed to sunlight, if big lots is there, 10,000, 20,000 lakhs of metals are there, like in denims, they cannot expose all 10,000 metals or lakhs of denim fabric to the air. So, what the extra process, oxidation process is used using any one of the oxidizing agents. These are all what I have taken. This data is from the books. But now in the industry 2023, textile industry, again developments might have taken place. That needs to be studied. Okay, now again converted into water insoluble form. Here dye, here SS sulfur linkages are react with the reducing agent and become SH. SH is a water soluble form, and that dye and SH water soluble after oxidizing, then it is again reconverted into dye SS dye and byproduct water. Okay, this is the mechanism involved in sulfur dyes. Friends, same in wet dyes also same is there. In wet dyes also water insoluble is converted into soluble and reconverted. That is wet dyes. Indigo, natural indigo is also a wet dyes. The- So now hope you have understood what is the structure of the sulfur dyes, sulfur black one, and this mechanism involved, the chemistry is involved in the sulfur dyes and dyeing process. It's common for all type of fabrics. First production, reduction, by whatever the sulfurizer that is reduced and dyeing taken place and washing, oxidizing, soaping, washing, then sulfurization, packing, other things. These are processes are there. Okay. Now, what type of shades can be possible? Already told sulfur dyes, black shade, sulfur dyes mostly preferred black dyes, or black and brown, and red is not possible. Red is not possible. And light shade is not possible. Medium shade is not possible. Dark shade, black, dark brown with bright tone is possible. Okay, for from the sulfur dyes. No light shade, pink color, yellow color, okay, light cream color is all no. And also, sulfur dyes are not used for printing of the fabrics. No, it's not for printing. Only for dyeing black, brown colors. Okay, so the limited is the limit is there for compared to other class of dyes. It's the limit is there. Okay, lighter shade, lighter shade. If you go for lighter shade, if by reducing the tones, if you go for light shade, it will not resist sunlight. Sunlight, if it is exposed to sunlight, shade will go out. And the plus point, and also this is a dull color. Sulfur dyes produce dull colors because black is a dull, brown is a dull, and other things are there. Okay, now here, what is the plus point of sulfur dyes? Plus point of the sulfur dyes: wash fastness. Wash fastness, fastness to water. What wash fastness, laundry fastness is very good because whatever the fabric dyed with the sulfur dyes, it is whatever the inside color is there, that is a water insoluble color. Opposite to the water, how can it come out? How can it will bleed? Even though keep 24 hours, even keep wash, it will color will not bleed in the washing. It is good wash fastness because of the low low solubility in water. Wash fastness is good, and also chlorine bleaching is avoided. It cannot be used. Chlorine bleach should not be used for sulfur dyed fabrics. But what's other is the bleach, hypochlorite. Hypochlorite bleach is advised for the hypochlorite bleach is advised, but chlorine bleach is not advised. Okay, bleach fastness is good if it is used hypochlorite. If chlorine bleach is used, no, fastness is poor. And also rubbing fastness, rubbing fastness is very poor because not only sulfur dyes, even though you dye fabric, reactive dye, direct dye, acid dye, whatever dye, you dye black color. Rubbing fastness is only poor. It is not 4. It is not 4 to 5, 4 grade. The fastness grade, what is called 4 to 5. No, it is always 1, 1.5 or 1 to 2 grade will be there. So even though for reactive dyes, black color grading is 1 to 2. Even if it is reached 2, it's far most better. In case of sulfur dyes, they were poor 1 to 5. Might be there fastness, rubbing fastness. Okay, now then application method. You know application method. Most of the dyes fabrics are applied. Temperature, what temperature? 80 degree is advised in the dyeing of the fabrics. First, whatever the dye solution is there, that solution should not be acidic in nature. That should be in alkaline nature. Why? The chemistry involved sodium. The chemistry is involved. Sodium is there. Sodium sulfide is there. Sodium is alkaline. So the solution should be alkaline pH. You have to maintain, the industry has to maintain pH. Huh? It should not 7 pH level. It should not be 7. More than 7, 8, 9, 10. Alkaline. Okay, now the H plus more than 7, 8 pH should be there because sodium sulfide is there. If the solution is acidic, highly concentrated, what will happen? This mechanism will not take place. this structure will be not there. Sulfur dyes, no use. So the alkaline pH should be in alkaline. So 8, 8, 9, 10 and other things. Okay now. And temperature 80 degrees centigrade, elevated temperature 80 degrees centigrade is good. Even up to 90 degrees centigrade is can be used to break the molecules of this insoluble dyes. Up to 90 degrees suitable. And sodium sulfides, okay, hydrosulfide and Glauber salt is also used. Common salt is required. Why common salt is required? Why common salt is required? To make it to make the efficiency, to increase the efficiency of the dyeing, exhaustion of the dyeing. Okay, to increase the exhaustion of dyeing, to increase the absorption of the color by the material, cotton or viscose or anything. The Glauber salt, common salt is used, is a common in the textile chemistry. And one more thing is that in founder, one more thing is that I'm telling you, after dyeing of the fabrics, even after conversion of the water soluble or leucoform into water soluble and washing, soaping and other thing, lastly what is required after treatment is required. One more important in this case is after treatment. Not only in this, in any textile process, after treatment is the most. Sodium acetate is used for after treatment. Why after treatment is required? The fabric or yarn dyed by the sulfur. You see, friends, SH is there. Correct. SH, whatever the SH is there, okay, sulfur is there. Corrosive in nature. When this S2SH, the dye water is insoluble, SH2 is there, SH is sulfur is there. After treatment with the sodium acids to suppress S2S, see here, S2S is there. Corrosive to the metal, whatever the byproduct is there in the sulfur, S2S is there. S and S2 is there. Reaction, the byproduct will appear. That S2S, that is what will happen. That make the metal item, if any, then the processing, any machineries are there, any helping instruments are there. If it is made of iron, then that S2S byproduct, whatever is there in the sulfur processing, that make that iron a corrosive, corrosive, jung, okay na? That make corrosive metal sulfide, S2S, the byproduct, it makes corrosive metal sulfide, S2S, it makes, because if not immediately, in the atmosphere, in the humid atmosphere, that S2S makes that metal item corrosive. That is the reason in all whole the process, whatever the dyeing process are there, what the dyeing machines are used, continuous dyeing you take, batch process you take, whatever the machines, bench machine or jigger machine or uh, continuous batch process, whatever they use, what will happen? It should be made of stainless steel. Machines are made of stainless steel. For stainless steel, the corrosion will not take place, especially for sulfur dyeing. All metal items, processing, mechanical devices are there. Those are not made of ferrous, means iron. Fe ferrous react with S2S in the humid condition, makes ferrous sulfide and S2. It is a ferrous sulfide and S2. The device, mechanical device, will get corrosive. That is the reason it should be stainless steels. Okay, so and also sodium acetate after treatment with sodium acetate to suppress. So whatever the byproduct I told S2S, to suppress this, to suppress production of the S2S, to reduce this unwanted reactions, corrosive reactions or byproduct the fabric is treated with, or the after treatment is required by using sodium acetate. Hope you have understood on this topic sulfur dyes. Friends, whatever the textile chemistry is there, we can talk more. Subject is more. This much of volumes books are there written by the authors. Okay, so we cannot say all those things in the videos. You can read in your students. You can read. Go to your library. Go and read. Whatever we are teaching online in this video class or your lectures are teaching on the dais in your classroom, that is just knowledge, but that knowledge will not help. Go and sit in the library and refer, not for the passing of the examinations, for your future career. Once the knowledge is built in the brain, that is forever, that cannot be thieved by anybody. Okay, now hope you have understood on this small means I think half an hour, no, 1 hour, no. Okay, whatever time, okay, whatever time this topics on sulfur dyes. Friends, please subscribe. Those who are not yet subscribed our channel, Guruvira Textile and Fashion Technologies, please subscribe to our channel and click the icon bell for all to get the notifications in your mobile device or laptop or any devices, and encourage us and ask your friends to watch our videos, those who are all students, lecturers and other things in this people. Okay now, and please help to increase the subscribers and help to watch and give promote my channel. And also I'm going to say that I am selecting a subject in my channel, but you can send comments which topic you want class. In if you are a diploma student, if you are a BTech student or B engineering or Bachelor of Technology Engineering or MTech, whatever subject you want, send me the topic. That topic I will take. I will prepare and take. 1 week time is enough. If you send the comment next week, you will get the video on this. Okay now. So thanks for watching this class sulfur dyes, and next Sunday I will come with the other topic what I am preparing. Then if you send today a chapter, then that chapter will come. Thank you so much. Thank you so much. Close. End. End. Okay, 1 minute.